Okay, now welcome back from the team of Teach Nagaland. I hope all of you are studying at home, going through these videos, especially class 12 students. At least during this time, if you go through these videos thoroughly, at least you will be able to finish up completely one unit. And if you need any help on any chapters, please feel free to email us so that we can help you. Now, proceeding from the previous video. Chapter 4, class 12 mathematics, exercise 4.6. Now in the previous video, introduction video, we have discussed about how matrix and determinants can be used to solve a system of linear equations. Now let's put that to practice and see how we can really do it. Before that, a brief recap of the previous class. That is, if a system of linear equations is given to you, then it can be written in the form of ax equal to b. A denotes the matrix of the coefficients of the variables, x the matrix of the variables, b the matrix of the constants. And if determinant of a equal to 0, then it will have a unique solution, and then we will proceed further and solve and get the variable solutions of the variables by this matrix method, x equal to a inverse into b. If determinant of a is equal to 0, then two cases arise, that is, you will find out the product of adjoint of a into b. If it is not equal to 0, no solution. If it is equal to 0, then it will have infinitely many solutions. Now if you look at the exercise, that is exercise 4.6, the first question that states, the first set of questions, examine the consistency of the system of equations. We have seen that only for this case we will say that this is inconsistent. This will be consistent, and this will also be, they should have at least one solution, then we will say that this is consistent. Now let's try. So I'll just write here the given equations are x plus 2y by equal to 2, 2x plus 3y equal to 3. So with that said, I'll just mark this as equation 1, I'll mark this as equation 2. Of course it does look a little bit messy, isn't it? So let's not try to write it like that. So it's not good, no, isn't it? So let's try to write it more properly. The given equations are, we should not be lazy, right? So if I am being lazy, then gone, no? 3y equal to 3. So then let a, so this will be a 2 by 2 matrix because we have only two equations, two variables, so definitely it's simple. Of course 2 by 2 matrices are all using the old method that we have learned in the previous classes by finding out its ratio a1 by a2, b1 by b2. That will also be very helpful. This method generally for bigger equations, but yes, we can do it here also, no problem with that. So let's see how it is done. So this will be the coefficients of the matrix of the coefficients, x the matrix of the variable, that is simply x and y, b coefficients of the matrix, the matrix of the constants. Here the coefficients are 1, 2, here coefficients are 2, 3, and the constants are 2 and 3. So let's first find out determinant of a, that is 1 into 3 minus 2 into 2. So that is 3 ones are 3 minus 4, that is minus 1. So determinant of a is not equal to 0, so there is only one solution for that, that this will be of course definitely consistent, and of course, and it will have a unique solution. Moving on to maybe question number 3. The given equations are x plus 3y equal to 5, 2x plus 6y equal to 8. Equation 1, equation number 2. So here let our matrix A 1, 3, B 2, 6, the matrix X variables x and y, the matrix B constants 5 and arbitrary constants, or not arbitrary constants 5 and 8. Let's find out its determinant A, that is 1 into 6 minus 2 into 3. 6 minus 6, that is equal to 0. So it will be either of the two cases, case 1 or case 2. Let's find out the adjoint of A then. For adjoint of A, remember we will first have to find out the minors. M11, M12, M21, M22. So M11, that will be, okay, let me write down the matrix once again. 3, 2, 6, if I'm not mistaken. 1, 3, 2, 6. So for M11, ignore the first row in column, so that's going to be 6. For M12, this row, so that will be 1. For M21, this row, this column, so that will be 3. For M22, this row, this column, that's going to be 1. For M12, I think we've made a mistake. For M12, that's fine. M22, that will be again 1. No problem with that. I am still very fishy about this. Let's do this once again. Let's do it properly. Sometimes it gets very confusing, no, with this matrices and all. One lapse of concentration, done. So for this, it's 6. For M12, it is 1. No problem with that. For this, it is 6. For this, sorry, for M12, it's going to be 2, isn't it? Let's check that once again. See, that's why I was having some small doubts, no, there, because all 4 elements would be different. So for M12, this row, this column, so it will be 2. So finally we have rectified. A11, A12, A21, A22. You can even use C also, okay? So A11 will be 6, A12 minus 2. We have already done enough of this. Minus 3, 1. So adjoint of A shall be transpose of the matrix formed by the cofactors. So 6 minus 2 minus 3, 1. 6 minus 2, 3, 1. So now let's get its product. Adjoint of A into B. 6 minus 3 minus 2, 1. Our matrix B. What was our B? Our matrix B, 5, 8. 5, 8. So 2 by 2 matrix, 2 by 1 matrix. So we will have a 2 by 1 matrix. So 2 by 1 matrix. So that is A11, A21. So first row, first column, 6 5s are 30 minus 8 3s are 24. Next, A1 to second row, first column, 2 5s are minus 10 minus 8. So we have 6 minus 18. So definitely this is not equal to a 0 matrix. So in that case, so if it is not equal to 0 matrix, this will be the second case. In that case, it will be inconsistent and it will have actually no solution. So this will be inconsistent and no solution. So this is how it will be done. So I request you to kindly concentrate, because we have already seen here with one problem that one small lapse in concentration, everything might just go off. So luckily for us here, we could rectify our mistakes. But when we do big matrices of 3 by 3, 4 by 4, then we may not be, it will not be very easy to rectify our mistakes. So I hope you have liked this video. Please do subscribe and learn from this videos, which is completely meant for the students. Our only concept is that the students should not sit idle at home, make the most of it by learning from these free audio classes that we are providing for you. Thank you so much.